We're going to
discuss about the unit circle. First, the trigonometric functions of the unit areas. Here are some examples.
It's from our test.
P 5 over 3. First, you have to find in your index card where it belongs in the quadrant. So 2 pi over 3 belongs to quadrant 2. So it would be negative 1/2 and square root of 3 over 2.
You might be wondering why this is negative. It's because in quadrant 2, the x is negative and the y is positive.
And this is the final answer.
You're just going to copy what's written in the index card. Example number 2, another example.
Number 2 is P of 4. So,
Look at the index card.
look at your index card.
It's
So
5 pi over 4. This is 4.
5 pi over 4, it is in
Quadrant
3. So, it would be
both are negative. Negative square root of 2 over 2
and negative
square root of
2 over 2.
And this is already the final answer.
And this is the final answer.
Now let's talk about the trigonometric functions. These are the formulas: sine theta, cos theta, tan theta, CSC theta, secant theta, and cotangent theta. And let's have an example. First, let's do the sine theta. Sine theta, find the value of the given trigonometric function. The given is sine theta 5 pi over 6.
Using your index card, you find 5 pi over 6.
So it's in quadrant 2.
Quadrant 2.
And since sine theta is y, we're just going to use what is y. The y-axis of 5 pi over 6 is 1/2.
Positive 1/2 will be our answer.
So this is the final answer. Next, cos, and our next example is cos theta. The example is cos 3 pi over 4.
Using your index card, you find
3 pi over 4.
3 pi over 4. It belongs to the second quadrant. Yeah, negative and positive. So, using the formula, you would only find the x. So the x here is
the x of 3 pi over 4 is square root 2 over 2. Negative, it's negative. Negative square root of 2 over 2. Next example is tangent. This is our next example, tan 3 pi over 2. The formula of tan is y over x. In our index card, 3 3 pi over 2 is found on the fourth quadrant. And the formula for the x and y axis. And now for tangent, our example is tan 3 pi over 2. The formula of tangent is y over x. So on our index card, the y is negative 1. So it's negative 1 over 0 because the x is 0. And since the denominator is 0, the answer is undefined. So this is the final answer, undefined. For CSC, the example is 7 pi over 6. The formula of CSC is 1 over y. So in our index card, 7 pi over 6, the y is 1/2. So it will be 1 over 1/2. And since 7 pi is in quadrant 3, this is negative. So to find for the answer of this, we must multiply both of this. So it will be 1 times, and the reciprocal of the denominator, negative 2 over 1. Reciprocal, we should interchange the two of this, 1 and 2. So 2 will be the numerator and 1 will be the denominator. And this one, it is over 1. We will cross multiply, it will be negative 2 over 1, or negative 2. The final answer is negative 2. And now, let's have an example for secant. So example is secant 2 pi over 3. The formula for secant is 1 over x. So we're going to look for x in the index card. So in our index card, 2 pi over 3 is here in quadrant 2, and the x is 1/2. It's negative, so it will be 1 over negative 1/2. And again, we'll multiply the numerator and the denominator. It will be 1 times negative 2 over 1. We're going to cross multiply. Negative 2 times 1 is negative 2. 1 times 1, 1. And negative 2 divided by 1 is negative 2. So negative 2 is our final answer. And lastly, for cotangent, our example will be cotangent 7 pi over 4. And the formula for cotangent is x over y. So we need to find the x and y in our index card. So 7 pi over 4 is here. The x is positive square root of 2 over 2 and the y is negative square root of 2 over 2. And again, we'll need to multiply these two of them. So it will be square root of 2 over 2 times negative 2 square root of over square root of 2, because this is the reciprocal of this one. We need to interchange the two of them. Since we have common here, we can cross this out, and what's left is negative 2 over 2, and you'll divide this. Negative 2 divided by 2 is negative 1, and the answer is negative 1. That's all.